Hello, this is the NASA Mars Lander final report for first year engineering lab section 7 in the fall of 2025. A brief overview of what will be discussed in this presentation. We will begin with team introductions, then review the background and requirements provided in the official request and proposal, and after that we will show our final design and walk through the manufacturing and construction plan and present our test results and finish with the final conclusion and takeaways. Our team is the Omelet Operators. I am Jordan LaVega. I will be the project manager presenting today. Maria Melo Fontoura is the construction manager, and Simone Supar is the test and verification manager. This slide shows the official request for proposal we were given at the beginning of the project. NASA is seeking a contractor to design a demonstration model for a Mars landing vehicle that can safely deliver 2 pilot eggs from a height of 12 feet without damage. The vehicle must complete 2 consecutive drops with no repairs in between, and the entire design must only use approved materials that stay within the $15 cost limit. We are also required to create a recorded final report showcasing both our design process and our successful test results. These are the custom requirements which summarize NASA's expectations at a high level. The lander must safely deliver astronauts represented by our 2 egg pilots to the surface, and it must be reusable, meaning it must survive both drops without structural failure, and all performance must be demonstrated on launch day with video testing. These are the contractor requirements. These contractor requirements give more detailed engineering constraints. Our lander must withstand a 12-foot drop, protect 2 eggs that weigh up to 59 grams each, and maintain full structural integrity between the first and second test. We must also meet the $15 material limit and only use materials from the approved list of salvage materials. The second half of the contractor requirement outlines additional engineering expectations. The lander must reduce impact force, prevent any ejection or exposure of the pilots, and minimize rotational motion during descent. It must also have a controlled descent mechanism, such as a parachute, designed to lower its terminal velocity. Finally, all internal components must stay secured so nothing shifts, separates, or impacts the pilots during the landing.
Hi, I'm Maria Fontoura. I'm the construction manager for the Omelet Operators, and these are our final design drawings. In the front view, our spaceship had 2 Walmart bag parachutes tied to the main frame using string, or in the case of our final build, rubber bands. And that's what those ringlets that you see there in the drawing represent. The main frame of our spaceship was 2 3-sided pyramids made of intersecting paper straws. In the hollows of each pyramid, we place each of our egg pilots, Captain Kirk and Dr. Spock. We also reinforced all the intersections with tape and rubber bands, which is represented by these small black rectangles that you see on the first drawing, and the fluffy ovals that you see on every corner of the pyramid is a cotton ball that was skewered onto the structure. The finer details from the front view were omitted in the side view and the top view for better clarity. We made no changes for the original plan for materials purchases. However, the final spaceship left behind lots of materials. We did not use the cardboard, not the copy paper, and we did not use the special salvage request material, which was twine. We were afraid that maybe our design choices might not work in the end. That is why we bought at least one of every item just to be safe. Now, this is our construction plan. First, step 1. You need to acquire a 1 foot by 1 foot square sheet of bubble wrap and cut that into 2 equal 6-inch by 12-inch rectangular sheets of bubble wrap. Set that aside for now. Unravel 10 to 20 cotton balls into long strips and lay an equal amount of them flat against the smooth side of each sheet of bubble wrap. Grab tape and strap down the bits of the cotton balls to the bubble wrap sheets. Grab your pilots or grab your test dummies and wrap them in these cotton lined bubble wrap sheets. First, you're gonna wrap two edges one over the other just like you would for a paper airplane, and the remaining edge you can just fold over the entire structure, and then with copious amounts of tape together any corners that might be falling apart. One particularly long piece of tape, about 6 to 10 inches, you should wrap like a belt around the entire egg pod that you've just created. This will serve as a door to open and close the pods and allow your pilots to embark and disembark. Now for step 3, build the straw frame. Grab 12 straws and arrange 6 of those straws into 2 planar triangles and 6 of the straws into 2 teepee-shaped upright triangles. You're going to slide the planar triangles together with these upright triangles to form your 3-sided pyramids. 2 straws remain. Grab them and place them parallel along the bases of both pyramids so that now you will have 2 sets of straws parallel to each other and able to be connected and rubber banded together to keep both pyramids as one. Then, step 4, you need to install the egg pods inside the hollows of each triangular pyramid. Just shove them in there very carefully and use lots of tape to form walls along the once hollow portions of the inner parts of the pyramids. Now, for part 5, add external shock spikes. You grab your remaining cotton buds and you skewer them onto the edges of your pyramids, and grab tape once again and make sure to tie them down carefully to those edges of the spaceship. For part 6, assemble the parachutes. Grab 4 Walmart plastic bags and then double line them, which means you will grab one, shove another Walmart bag inside it, and repeat for 2 parachutes. Then grab tape and reinforce the inside corners of each of the parachutes so that they don't fold inwards on themselves as much. Now, for part 7, you cut 4 long pieces of string around 10 to 12 inches and tie them with a knot around the handles of the Walmart bag parachutes, and then tie them once again with a knot back to the tops of the pyramid structures, the tippy tops. Make sure to drop it from about like waist height or shoulder height, and to make sure that all the strings are in place or that nothing comes loose. What went different when we finally really built the thing? Well, we modified that hatch by adding way more layers of tape. We realized that only one belt of tape was not enough. We also reordered some of the assembly steps because during building, the egg pilots were not available sometimes, and sometimes dummies were also not available during construction. So we assembled the full body of paper straws first, and only then crafted the egg pods and inserted the pilots in immediately before launch. We also gave the parachutes more distance from each other by placing their strings, which in the end were rubber bands. This also changed from the initial plan. Further apart in the structures at corners of the pyramids instead of only on the tippy top of the pyramid. And we accidentally placed the parachutes upside down at the bottom of the pyramids, but this did not impede the descent at all. The pyramids were just pointing down as they fell, but all was okay. This, the first one, is the top view because the parachute strings are under the entire structure. And so the little tops point upwards and there's a little hole in the cotton, and that's where our pilots were placed. The front view is the front view because, as you can see, the bag strings are parallel this way to the rest of the structure. And now the hole that I mentioned earlier, the hole in the cotton, is kind of more upside down. And the side view is the side view because we see one of the nubs made of cotton, and then the other nub is obscured because we're seeing it at a diagonal.
Hello, my name is Simone Stupar, and I am the Test and Verification Manager. I will present the official DD250 test plan, the verification results, and final findings from both drop tests. Testing occurred on October 8th at the FAMU FSU College of Engineering campus at a measured launch height of 11 feet. Prior to each test, the DD250 procedure required verification of the lander's length, width, and height, as well as 4 photographs documenting the vehicle condition. A 360-degree pilot integrity inspection was also completed to confirm that both pilots were undamaged before loading. For drop 1, the load time measured 40.88 seconds. The lander descended from 11 feet and both pilots remained fully intact after impact. The lander frame retained structural stability and no components detached or shifted out of place. Before drop 2, the verification process was repeated. The unload time before the trial measured 54.10 seconds. After drop 2, the load time measured 56.07 seconds, and the final unload time measured 50.77 seconds. Both pilots again remained undamaged, and the structure continued to perform as designed. All fields of the DD250 form were completed. All collected data was accurate, and each box in the official sign-off column contains a signature. As a result, the team earned the full project revenue value of $100,000. This slide contains the video evidence for both drop tests. In the Test 1 video, the lander demonstrates a stable and controlled descent. The parachute deploys symmetrically, and the vehicle maintains orientation with minimal rotation. The descent behavior confirms the attached system and mass distribution supported aerodynamic stability. Here is the Test 1 video. For the Test 2 video, this one demonstrates consistent performance. Even after completing the initial drop, the lander descends with similar control. The parachute remains fully opened, and the frame does not rotate excessively. The pilots remain secure within the structure throughout the fall. Here is a Test 2 video. Both videos meet the verification requirement for visual confirmation of acceptable descent behavior. This slide presents the physical condition of the lander and the pilots immediately after both tests. The 2 images on the left document the condition after drop 1. The frame remains intact with no broken straws or detached joints. The padding maintains its intended position and the interior configuration does not shift. The corresponding pilot inspection image confirms that both pilots show no cracks or visible damage. The 2 images on the right document the condition after drop 2. Even after experiencing cumulative structural stress from 2 impacts, the frame retains stability and the parachute attachment points remain secure. The pilots again show no cracking or structural compromise.
To conclude our final report, I want to summarize the major outcomes of our design, assembly, testing, and redesign process. First, in terms of design, our lander used a lightweight triangular straw frame combined with cotton and bubble wrap padding to protect the pilots. We attached a dual bag parachute system using rubber bands, which helped stabilize the descent and reduce rotation during the drop. For assembly, our team completed the entire frame and parachute system first. Since the eggs were not available beforehand, we then finished the internal padding and added a small entry point so the pilots could be safely inserted at the drop site. In terms of test results, both drops showed stable descent and very minimal rotation. Most importantly, both pilots landed safely without cracks, and the lander maintained its full structural integrity after test 1, allowing us to meet the reusability requirement. Finally, regarding rework and redesign, we replaced the original string connections with rubber bands for better parachute stability, and we also adjusted the padding layout and restructured our assembly order in order to accommodate last-minute pilot insertions on launch day. Overall, our design successfully met all major customer and contractor requirements, and our team demonstrated strong problem in solving and adaptability throughout the project.